Dear students, today I am with another video and I will be taking another problem, that is assignment problem. We'll be solving it through Hungarian method. So what is assignment problem? In assignment problem generally we have certain number of machines which have certain number of jobs to be performed, right? So our aim is to assign all the jobs to different machine in order to minimize the cost, right? So see, look at the board, we have got certain machines and certain jobs. So our work is to assign the job for different machines so as to minimize the total cost. That means we have to assign all the jobs to all the machines to minimize the total cost, right? So this is the case of minimization of assignment problem, minimization case, right? So what we'll be doing, how we'll be solving it, just look. First of all, we need to find out the first modified matrix, right? How we'll be calculating the first modified matrix? We will be finding the minimum element in all the rows, right? So the minimum element is 8 in the first row, then it is 9 in the second row, then it is 4 in the third row, it is 6 in the fourth row, and then it is 12 in the fifth row. So these are the minimum elements in respective rows. So now what we need to do, we are going to draw another matrix, the first modified matrix. So we need to deduct this minimum element from all other elements in respective rows. So this will be 13 minus 8 is equal to 5. This will be 8 minus 8 is equal to 0. This will be 16 minus 8 is equal to 8. It will be 18 minus 8 is equal to 10. It will be 19 minus 8 is equal to 11. So these are the elements of the first row. For the second row, the minimum element is 9. So 9 minus 9 is equal to 0. 15 minus 9 is equal to 6. 24 minus 9 is equal to 15. 9 minus 9 is equal to 0. 12 minus 9 is equal to 3. These are the elements of the second row. For third row, the minimum is 4. So 12 minus 4 is equal to 8. 9 minus 4 is equal to 5. 4 minus 4 is equal to 0. Again 4 minus 4 is equal to 0. Again 4 minus 4 is equal to 0. So these are the elements of the third row. Now see, for fourth row, the minimum element is 6. So 6 minus 6 is equal to 0. 12 minus 6 is equal to 6. 10 minus 6 is equal to 4. 8 minus 6 is equal to 2. 13 minus 6 is equal to 7. Then for fifth row, the minimum is 12. So 15 minus 12 is equal to 3. 17 minus 12 is equal to 5. 18 minus 12 is equal to 6. 12 minus 12 is equal to 0. 20 minus 12 is equal to 8. So these are the elements of the first modified matrix. Again, I am repeating what we have done. We have found out the minimum element in all the rows, and then we have deducted that element from all the respective elements of that particular row, and we have found out the first modified matrix. Now the similar procedure we have to do for the columns as well. We need to find out the minimum element in different columns, and then we have to deduct that minimum element from all the elements of the respective columns. So look at the board, you can see that in all the columns the minimum element is 0. So when we are going to deduct 0 in all the elements, there will be no change in different columns. So we are going to write second modified matrix and we are going to copy the same because there will be no change. So it will be 5, it will be 0, it will be 8, it will be 10, and it will be 11. For the second row, it will be 0, 6, 15, 0, 3, then 8, 5, 0, 0, 0, then 0, 6, 4, 2, 7, then 3, 5, 6, 0, 8. So this is our second modified matrix. Now further, what procedure we need to do? We need to draw minimum number of lines in order to cut all the 0. That means our number of lines should be minimum and we have to cover all the 0. So we have drawn this line, right? Then we have drawn this line, correct? And then this line, and lastly this. So see, the number of lines capital N is equal to 4, right? And the order of matrix small n is equal to 5 because it is 5 by 5 matrix. So we see that number of lines are not equal to order of matrix. So we cannot have the assignment now until and unless the number of lines are equal to order of matrix. So we will be moving ahead for further procedure. What we need to do further, we need to identify the minimum uncovered element, right? And then we have to add this uncovered element at intersection points, and we have to deduct it from the all uncovered elements, right? So see, the next modified matrix right, see, this will be 5, this will be 0, this will be 8 plus 3 is minimum, right? So 3 is minimum uncovered element, so we'll be adding 3 over here because it is an intersection point, so it will be 11, then again 0, and then 3. For the next column, it will be 0, it will be 6, again see, 5 is intersection point, so we'll be adding this minimum uncovered element. 5 plus 3 is equal to 8, then 6, and then 5. Then for next one, 8 is uncovered, so 8 minus 3 is equal to 5. 15 again uncovered, so 15 minus 3 is equal to 12. 0, and then 4 again uncovered, so 4 minus 3 is equal to 1. So 6 again uncovered, so 6 minus 3 is equal to 3, right? For the next column, see, 10, 0, again this is intersection point, so 0 plus 3 is equal to 3, this will be 2, and this will be 0. Then again for the fifth column, 11 uncovered, so 11 minus 3 is equal to 8, 3 minus 3 is equal to 0, then again this will be 0, this will be uncovered element, so 7 minus 3 is equal to 4, and then 8 again uncovered, so 8 minus 3 is equal to 5. So this is our next modified matrix. Now further we need to do the similar procedure. We have to draw minimum number of line in order to you can say cut all the 0. So we are going to draw minimum number of lines. So this is the first line we have drawn, this is the second line, right? And this is the third, this is fourth, and this is fifth, right? So now we can see that number of lines capital N is equal to 5, and the order of matrix is also n is equal to small n is equal to 5. So now we can have assignment because our number of lines are equal to order of matrix, right? So we'll be making the next matrix, right? It will be 5, it will be 0, 5, 10, 8, then 0, then 6, 12, 0, 0, then 11, then 8, 0, 3, 0, right? Then 0, 6, 1 2 4, then 3 5 3 0 5, right? So these are the elements. Now we can start assigning the job, right? So always remember, we will start our allocation where we have minimum number of zeros. So first of all we need to assign from there, right? So we start our assignment over here, right? So once we assign here, then all the, you can say, other zero in that particular column or row will be cut, right? So it will be cut, right? Now we can move for further assignment. So we are going to assign over here, right? So the other zero in that particular column or in that particular row will be cut. So this will be cut, right? Next, further we are going to do the next assignment. So how will be doing that? We are going to choose this one, right? Correct. So this will be cancelled, right? And then for the next one, this will be our assignment, and for first row this will be assignment. So now we can see that in all the rows there is at least one assignment, right? So always remember, in all row there should be one assignment, not more than one assignment, right? All the 5 jobs have been assigned to 5 machines. We have reached to optimal solution, right? So we had machine 1 2, sorry, not machine, it is jobs 1 2 3 4 5 and machine A B C D and E, right? Correct. So all the 5 machines have been allotted all the 5 jobs. The first job will be performed by machine B. The second job will be performed by machine E. The third job will be performed by machine C. The fourth job will be performed by machine A. The fifth job will be performed by machine D. So all the machines have been allotted different jobs, right? Now we can calculate the total cost. Total cost, how will be calculating? Just look at the first matrix. The first job will be performed by machine B. So what was the total cost? Total cost for first job at machine B was 8. The second job has to be performed by machine E. So what is the cost? It is 12. The third job has to be performed by machine C. So at third job, what is the cost? It is 4. Plus the fourth job has to be performed by machine A. So what is the cost? It is 6. Plus the fifth job has to be performed by machine D, right? So what is the cost? At D, the cost is 12, right? So the total comes to 42. So this is the total cost, total minimum cost, when we are going to perform all the 5 jobs with 5 different machines. So this is all about Hungarian method, and this is the minimization case of Hungarian method. So further in our next video I will be solving maximization case, right? Thanks a lot.